Let's try to solve some more problems on RL series circuit with forced response. This is 5 Henry and this is the current through the inductor. This is 6 ohm. This is 2 ohm. This is 10 volts. And this is 40 volts. This is 40 volts. And this is 4 ohm. So this particular switch is closed at t equal to 0. This particular switch is closed at t equal to 0 seconds. So whereas there is another switch, so this is closed at t equal to 1 second. Right. For this circuit, calculate I of 0.5 second and I at 2 second. Calculate the inductor current for 0.5 seconds and for I equal to 2 seconds. All right. So initially, these two switches are open. So initially, these two switches are open. Right. So how to solve? So for these kind of problems, right? So let us start from, so you have a timeline. Right. So this is starting from minus infinite and this is t equal to 0, right? And this is t equal to 1 second. And again, this is infinite, right? So from minus infinite to t or minus infinite to t equal to 0. So what is the inductor current? What is the inductor current? From minus infinite to 0, what is the inductor current?
So 0.
0, right? So no initial conditions are given, right? So from the circuit, so both switches are open, right? This is t equal to 0, this switch is closed, right? And this is closed at t equal to 1 second. So both are 0. So that means the initial conditions, in other words, I 0 minus equal to I 0 equal to I 0 plus. So this is equal to 0 amperes. All right. So if you notice that, so there are two switching instants. So one is t equal to 0 seconds, one switch is closed, and t equal to 1 second. So there is another switch is closed. All right. So now, right. So here, first thing is at t equal to 0, what we have to do is we need to find out the response for t greater than 0, assuming that, so this is the condition, that switch is closed, this switch is closed, right? So we'll find the response of I of t. So we'll find the response of I of t. But the thing is that at t equal to 1 second, at t equal to 1 second, so there is another switch which is closed. Right? There is another switch which is closed. So when you're calculating or when you're finding out the response for this circuit, so what is the initial current through this inductor? What is the initial current through this inductor?
4
T
ampere.
equal to,
Sir, 4 ampere.
4 ampere, sir.
how you are calculating the 4 ampere?
At 0.
Sir, at t equal to 0, switch is closed.
See here, this is for t equal to 1. See here, there are two things, right? So this response I of t can be divided into three parts. One is for less than 0, one is for 0 to, if it's t less than 1 second, and another one is for t greater than or equal to 1 second, right? So this is the thing, right? Agree? So you have one thing, you have another thing, and this is another thing, right? So it is having three responses, obviously, right? So when t equal to 0, when the switch is closed, so obviously the response will vary. Understood? So here this value is how much you calculated?
0.
So 0, right? So this value, you need to calculate, right? So this value you need to calculate. So here, so when you are calculating this value, you need to use, so this initial condition. Understood? Right. So here also when you are calculating the response for t greater than or equal to 0, so what we have to use? What is the initial current through the inductor when during a particular time?
So I at 1 second, sir.
I at 1 second, right? So here you will get some response, some a into e to the power of minus xt, you will get something like that, right? So in that, so substitute the value of I equal to 1. So that gives the initial condition for the second switch closed condition. Understood? So if you solve that, so you'll get more clear, right? So this is the condition, right? So now, first thing, so as usual, so when t equal to 0, at t equal to 0, so what is the response? Or for t greater than 0, so how the circuit will behave? So this is closed, right? This switch is closed here, and so this switch is open, right? And there is so this is the condition, right? So 0 less than t less than or equal to 1, so both are equal, so there is no big difference here, right? And what is the circuit? So this is 40 volts here, so this is 4 ohm, and this is 6 ohm, and this is 5 Henry. Okay, so what is the response for this circuit?
4 into e raised to minus 2t.
4 into,
E
so
raised
what is
to
the
minus
initial
2t.
voltage that is given, right? If you know the initial voltage, the response is Vs by R into 1 minus e to the power of minus t by tau, right? Okay, so what is Vs by R? 4, right? So this is equal to 4 into 1 minus e to the power of minus t by, so what is the tau value?
50.
Tau here, L by R equivalent, right? So what is L by R equivalent? 1 by 2 seconds. Agree? So that means this will be minus 2t. Correct? Agree? Is this correct? 4 into 1 minus e to the power of minus 2t. So when there is initial condition is 0. Is this correct?
Yes, sir. Yes, sir.
Right. So this thing, so this is the response. This is only valid up to 1 second, right? Up to 0 to 1 second only, this is valid. Okay. So next step is we are finding out the response for t greater than 0. At t greater than 0, so the circuit is modified something like this.
T greater than 1 second. Sir.
T greater than 1 second, yeah, t greater than 1. This is closed, right? So this switch is also closed. This is 4 ohm, right? So what is the value of this one? 2 ohm. I think this is 6 ohm. This is 5 Henry. What is the voltage here? What is the source voltage?
10.
10 volts. Okay. So this is the circuit for t greater than or equal to 1. Sorry. Right. So now tell me what is its initial voltage? I of 1 minus equal to I of 1 equal to I of 1 plus, right? This is also valid, right? So what is I of 1? What is I of
So
1?
so 4 upon e square.
So that means 4 into 1 minus e to the power of minus 2 t, right? So substitute in place of t 1, right? So that is
Yes, sir.
I at 1. So what is this value? Four into 1 minus e to the power of minus 2. What is e to the power of minus 2? 1 minus e to the power of minus 2.
3.4586.
3.4586. That means 3.459.
Yes, sir.
Correct? 3.459 amperes. Okay. So obviously it is less than 4. So that means it is correct, I guess. So this is its initial condition, right? Okay. So what else you need to calculate? So you need to calculate I infinite, right? So for this circuit, so what is the value of I infinite? What is the value of I infinite?
Inductor will be short circuit.
So we can do KVL, sir.
We can do KVL. Yeah, I think, yeah, we need to do that. So this is I infinite, right? Or I. So how to calculate this inductor current? This is short circuited, obviously, right? So now you need to calculate the inductor or finite steady state. We'll find out. So what is that value? I think you need to apply at this level. So you apply KCL, right? So that gives you the inductor current, I guess. If you assume this voltage is V, right? So this will be, so what is the equation? What is the equation? V minus 40 by 4 plus V minus 10 by 2 plus V by 6 equal to 0. Is correct?
Yes, sir.
So what is the value of V? V by 4, that means 3V by 6 plus V by 6. So that means 40. And this is 110, I think. Tell me what is the answer.
Sir, I got current, sir, 2.727.
2.727 amperes. Check it this.
Sir, current,
Which
sir.
one? Okay, directly current you are saying. What is this
Yes, sir, I
voltage? Tell me
infinity.
first. So what is this? What is this value? Tell me first.
10.364, sir, voltage.
10.364.
16.364.
16?
16.364.
16.364. Okay. So 16.364 divided by the 6, right? So that is the current that is flowing. So how much you said? 2.727. You said something, right?
Yes, sir.
2.727. Okay. Just check this one. Check this one. I think it is correct. Okay. So what is the value of tau? What is tau? What is time constant tau? L by R equivalent. So what is R equivalent? So we said that, right? So this short circuit, this one. So this is also short circuit. We have two voltage sources, right? So voltage sources we need to short circuit. So now 4 and 2 are in parallel, right? So if 4 and 2 are in parallel, what is the resultant?
4/3, sir.
4 by 3, right? So 4 by 3 plus 6. So what is the final value? 5 by. So what is R equivalent?
22 by 3.
22 upon 3.
22 by 3
Yes,
or 2 by
22.
22, right?
22
by
upon 3.
3, right? So that means 15 by 22.
So 0.68.
Yeah, okay. So now, so what is the final response? So there is another one, right? So what is the response? I of t. So if you substitute this one, what you will get? What you will get, you will tell me. So the first one is, I think it starts with 2.727 plus 3 minus 4.27. So how much this is? What is the value here?
Sir, 0.732.
0.732. Okay. What is the value here? E to the power of minus 22t by 15. Correct? I hope this is correct, right? So this is for t greater than or equal to 1. This is for t greater than or equal to 1. Okay. You can also cross check this one if you substitute, right? If you substitute e equal to 1 second, right? So you will get the same thing only. Right. So this is not over. So here what is the question is, you need to calculate I equal to 0.5, the current at 0.5 second and the current at 2 second, right? So for current at 0.5 seconds, so where you need to substitute? For I 0.5 seconds. So what is the value for I 0.5 seconds? So will you substitute here?
No,
No,
sir.
sir.
Sir, in the
So
previous
this
I
is
of t,
wrong,
sir.
right? So this is after t equal to 1 second, right? So
Between
not
0
agree?
to 1 we have to say.
Yeah. So this one you need to substitute, right? So t equal to 0 if you substitute. So this is t equal to 0.5 seconds. So this is 4 into 1 minus e, right? I think 4 into 1 minus e only. What is the answer? So what is I of 0.5?
4 into 1 minus e power minus I, minus 1.
You think minus e, right? 1 by e.
1 by e, sir.
Yeah. E to the power of 1 minus 1 by e.
Two point five two eight.
2.52 ampere.
2.53
2.53 approx.
amperes. Okay. 2.53 amperes. For second case, so I think I 2 amperes, right? Or 2 seconds, right?
Excuse me, sir.
Yes.
Sir, here I have a doubt because here we took after 1 second we took a different circuit, na sir.
Yes, yes.
For that we found out I of 0 and I of infinity, no sir.
This one,
Yes, sir. The 3.459 and 2.7, sir. That thing.
where it is infinite? I'm not getting what's your doubt.
Yes, sir. We started from t equal to 1 and considered that to be as our 0, no sir, for this circuit.
Yeah.
So final equation we should replace t with t minus 1, no sir. In the final
yeah,
I equal.
yeah, that's I'm just changing that one. So this one, okay, right. So what is the value here? This is the one, right? That's a good point. Actually, I forgot to change that. So what is the value here? Can anyone tell? So instead of t, what you're
T
supposed to
minus
get?
1.
So it is t minus 1 only, right? Okay. So this is t minus 1. Okay. Good. I forgot that. I just I thought this same thing. Okay. So make sure that, so that is t minus 1. So when you substitute t equal to 0, so then only you will get the correct things. So now tell me what is I equal to 2?
Two 2.727. Substitute t equal to 2.
How much?
2.896.
2.896 amperes. Okay. I hope your substitute after changing to 2 minus 1, I think. Okay. So change it this 2 minus 22 into t minus 1 by 15. That is the correct representation. So take this an example, another one. Okay. So this is U of t volts. Okay. So this is U into t minus 1 volts, 3 ohm, this is 2 Henry, and this is 6 ohm. So this is the inductor current. So calculate I of t. So calculate I of t if I of 0 equal to 0 amperes. Calculate I of t. You're aware of this meaning, right? What is its meaning? What is the meaning of this one?
So right one has been closed at t is equal to 0 and left one at t is equal to 1.
What is its magnitude? What is the magnitude of source magnitude?
Sir, V, sir.
Why? Is there any meaning for V as the units?
Unit magnitude, sir.
So 1,
It's
sir.
unit magnitude, right? If
One.
nothing is given, it's unit. Something, if for example, 2 into U of t, so that meaning is 2 volts. Okay. So that means 1 volt source is closed at t equal to 0, and another 1 volt on this side, on the right side, on the left side, at t equal to 1 second, 1 unit source is closed. Okay. So try to find the response for this. And then, so this is about the first order circuits. This is about the first order circuits.
One show the previous slide.
Sir, we'll have to do it by our own.
Yeah, you have to do by your
Sir,
own
so then kindly write the answer, sir. We'll confirm.
answers for this. I don't have answers. I think it is in one book. I will provide the answers of the class. Okay.
Okay, sir.
So right now my desktop is closed. I have to turn on again. Okay. I will provide the answer. No problem. Right. So next one, I think This 50 ohm is 0.5 into I. Okay. This is 80 volts. This is 40 ohm. And this particular switch is open at T equal to 0. 3 farad. So this is 30 ohm. And this is the current I, the dependent source. Okay. So for this circuit, find I of t for t greater than or equal to 0. So there is another one. Two into u of t minus 1 this is a oh no, I think one capacitor is missing here. So there is a capacitor here actually, and its value is 50 microfarad millifarad. Okay, and this is 8 ohm. This is 12 ohm, and its value is 24 u of t. I will write its value here. 24 u of t minus of u t minus 1. Okay. So next we'll start the second order circuits. If you have any doubts on these previous problems, okay, you discuss in our group, so that we'll discuss if possible. We'll discuss in class. I will otherwise I will provide the solution. Okay.
Sir,
Yes.
once can you tell what is that U of T, sir?
You have to be discussed in one class.
Okay, sir.
Okay. So what is the meaning of this one? Anyone tell?
Sir, it means that the value, sir, of that is 24, sir, between 0 and 1 second, sir, and rest
Yeah.
time 0.
Yeah. Good. So that means it is at 0, it is closed. At 1 second, it is open. right? Okay, we'll discuss these things on our tutorial session. So next we'll start with second order circuits. Okay. So as we discussed in the previous, in the first class, the second order circuits are composed of two different types of energy storage elements, right? Two different types of energy storage elements. Okay, so usually inductor and capacitor, so that form a second order differential equation. So that's why it is known as second order circuits. So there is a little chance that even though if you have two inductors, that is also form a second order circuit, and if you have two capacitors, so that is also form a second order circuits. And that is one thing. Even though if you have L and C, so both of different variables are there, still the circuit is a first order only, so that possibility is also there, right? But the thing is that in most of the cases, if you have two different types of energy storage elements, so that means we can, most of the cases, it will fall under second order circuits. Okay, so the actual thing we can say, or we can conclude, that whether it's a first order or second order circuits, so only after developing the differential equation, so then only we can say that whether it belongs to first order or second order, right? So in second order circuit, so basically we have RLC circuits, series combination of RLC circuit, parallel RLC circuit. So what we will discuss in this, series RLC circuit and parallel RLC circuit, and another one is general RLC circuits. It may not be in series or parallel, it has some a different connection, right? So series RLC circuits, parallel RLC circuit, and general type of RLC circuits. Again, we'll discuss with natural response and forced response. In natural response and forced response. So when you talk about the natural response, again we have stored energy. If you have RLC elements are there, right? Stored energy in capacitor will present, and the stored energy in inductor will present. So that means we have V0, initial voltage across the capacitor, V0 will present, and the initial current through the inductor, so that I0. So both will present. So in previous case, if you have RL circuit or RC circuit, so you have either the inductor initial current I0 will present, or the capacitor initial voltage V0 will present, right? So now obviously you have two different types of we obviously have voltage, obviously you have capacitor and inductor, both are present. So therefore, so both is having initial voltages V0 and I0. So it is a differential equation of second order, right? To solve that differential equations, you require two initial conditions, right? So to solve that, you require two initial conditions, right? So in previous case, so what is the initial condition for solving the first order differential equation? So either voltage across capacitor or current through the inductor. So these two gives a initial condition to solve the solution for the first order differential equation. Similarly for second order differential equation, right? So you require two initial conditions. So what are those initial conditions is, so first you require V0 or I0. So another initial condition that you require is, so dVc of t by dt, or 2 Vc of 0 by dt, or d into I inductor current 0 of dt. So these two initial conditions are required. So why exactly these two are required? So that you will understand in later classes.
Sir,
Yes.
sir, second condition is the value at sir 0 second.
Yeah. The derivative of voltage across capacitor at t equal to 0.
Okay, sir.
Okay. So these two are required. So why exactly required? So that when you are discussing the actual circuit, so that you will understand. So right now, so we'll try to find, so how to obtain the derivative term at a particular time instant 0, or 0 minus or 0 plus seconds, or derivative at some time period infinite. So how we will solve those particular kind of problems, so we will study now. So that means the topic here name is initial conditions. So finding the second order systems, finding the initial values. finding the initial values. So let us assume that you have circuit something like this. Right. So this is 0.4 farad, and this is 4 ohm, and this is 2 Henry, and this is 6 ohm, and its value is 12 volts, and this particular switch is open at t equal to 0. So this is the voltage across capacitor V, and this is the inductor current I. So that one is inductor current I. All right. So for this particular circuit, find out I 0 minus V I 0 minus so for particular circuit, find out I0. So V0, right? So this is 1. Second, di0 by dt, di0 by dt, and dv of 0 plus by dt. So this is all plus I of 0 plus v of 0 plus di of 0 plus by dt, dv of 0 plus by dt. And the third one is I at infinite and v at infinite. So these are the things we need to find out. So how and why exactly these we will use in solving the second order differential equations, so that we'll study later. So to remember, for time being, so our objective is to find out the initial condition I of 0 plus v of 0 plus I di of 0 plus by dt, dv of 0 plus by dt, and similarly I at infinite and so v at infinite time. Okay. So how to find these values? So that we'll find out. All right.
For I of 0 plus, we have to do steady state condition.
I of 0 plus, so that is steady state, right? So what is the first one? I of 0, right? I of 0 plus. So can anyone tell? So what is I of 0 plus?
2 amperes, sir.
So how the circuit will be modified at t equal to 0, the switch is open, right? The circuit will be something like this, right? So we have inductor here, and so we have resistor here, and this capacitor is open circuited, and this particular inductor is short circuited, right? So now we have 12 volts, so 6 ohms, and this is 4 ohm. So what is this current I? What is this current I?
2 ampere.
12 by 6, so that is equal to 2 amperes. Okay. At the same condition, right? At the same condition, so what is the voltage across 4 ohm resistor?
4 ohm resistor.
So 12 volt.
12 volts, right? 12 volts. What is the voltage across this branch is also 12 volts. So that means V of 0 plus, so which is also equal to 12 volts. So I of 0 you found. So that means I of this is also equal to I of 0 minus, this is also equal to I of 0, and this is also equal to V of 0 plus, 0 is also equal to V of 0 minus. This is the basic equations so that we developed right at the beginning of the course. Understood? So now tell me, so what is dV of 0 by dt. You know value of dv0 of dt equal to 12 volts. So what is this value? So what is the particular value?
0 no, sir.
Why 0?
I think
Can you directly
not
derivate
zero,
that
sir.
one?
We have to apply.
Will it be can we
Now
directly
only the
apply on
right
that?
circuit is left.
Right. So here, this particular
Like-
condition, right? This particular condition is derived. So how exactly this you derived I of 0 plus? So this is under the impression that this I of 0 minus, you are sure that, so that is 12 volt. Oh, sorry. So we are first you calculate V of 0 minus, right? So this equivalent circuit for V of 0 minus. Agree? Okay. So here the basic thing that the capacitor voltage will not change suddenly. So therefore we are under the impression that, so this is also equal to a switch equal to closed. This is also equal to V of 0 minus, right? But the thing is that for V of 0 plus, the circuit is not this one, right? For V of 0 plus, this is not the circuit, right? So therefore you cannot directly differentiate that one. So therefore, so for V of 0 plus, so how the circuit will behave? So that means, so the circuit will be something like this. So you have 12 volts on one side. So this switch is closed. So this is your circuit, right? But T
Sir, sir, at t is equal to 0, the switch is open, sir.
open. Okay, okay. So then this is not there. So you left with a, so this is 6 ohm, this is 4 ohm, so this is 2 Henry, and this is 0.4 farad. All right. So our next objective is to how to find dV of 0 by dt. Right. So what is dV of 0? What is the voltage across the capacitor if you know the current? So this can be right in terms of current, right? What is that?
So C into dV by dt.
C into dV of 0 plus by dt, right? So this is equal to IC. Agree? So this is equal to IC. So what
Yes.
we have to do is we need to find out the capacitor current IC of 0 plus. Okay. So this is equal to IC at 0 plus, right? Agree? This equation. You
Yes, sir.
accept this equation? Right. If you calculate the capacitor current IC at 0 plus time, IC at 0 plus time, so you can calculate or you can obtain the C into dV of 0. So from that you can calculate. So V at 0 instant, right? So now how to calculate IC at 0 plus instant? IC at 0 plus instant.
So we'll equate it with, sir, IL, sir, at 0 plus.
So if
Sir,
you
first
apply,
take a
right,
case.
this is the one, right?
Yeah.
So this is capacitor current IC, right? And this is inductor current IL. Agree? Agree? Understood? So
Yes,
now
sir.
the question is, right, so now you observe that, so if you apply KVL or KCL at t equal to 0 plus seconds, at 0 plus seconds, if you apply KCL, right? So what is the equation, tell me? So both are outgoing currents, right? So can it be IL 0 plus plus IC 0 plus, so which is equal to 0, agree?
Yes, sir.
Right?
Why you
So
put
you know
that
the
dot
value
in
of inductor current at 0 plus, right? What is the inductor current at 0 plus?
2, sir.
So 2 amperes, right? So this is equal to 2 amperes. So therefore IC of 0 plus. So what is the value of IC of 0 plus?
-2.
Minus 2 amperes, right? So this is minus 2, right? Now come back to here. So now tell me what is the value of this dv of 0 by dt. So you obtained IC of 0 plus equal to minus 2 amperes. So you know the basic thing that this C into dv of 0 plus by dt, so which is equal to minus 2 ampere. So from this v of 0 plus dt, so what is this value? So what is this value?
-5.
-5.
Minus, that is minus 2 by 0.4. 0.4 only, right? Yeah, 0.4. So that is minus 5. What are its units? What is the units for this one?
So volt per second.
Volt
Yeah,
per
volt
second.
per second. Understood? So that is volts per second. So this is how we will calculate the rate of change of inductor current at t equal to 0 plus. So for that, so what we have to calculate is capacitor current we need to calculate most cases. Right. Okay. So similarly, so what is the next step? So inductor current I d of 0 plus by dt. So this is the one we need to calculate, right? So this is the second task. So for that, so what we can calculate? What we can calculate? So this can be written as d into I of 0 plus by dt. So what is this value is inductor voltage at 0 plus instant. Agree?
Yes, sir.
Okay. Inductor voltage at 0 plus instant. So somehow we need to find this VL of 0 plus. Right. So you have a circuit something like this. Okay. You have a circuit something like this. So this is I and this is IC. So this is IC. So how to calculate VL of 0 plus?
Sir, we
Using
can
KVL.
apply KVL, sir.
We can apply KVL, right? So we can apply KVL. So which current will be the, right? If you apply, this is the I. So this IL, right? So tell me what is this? What is the value of this one? So this is 6 ohm, and this is 4 ohm. And what is the value here?
0.4.
0.4 volts, and this one 2 Henry. So now apply KVL at t equal to 0 plus time, right? So what is the KVL at 0 plus time? So this is the voltage across capacitor, right? This is V of 0 or V of V simply, right? So now tell me what is the KVL equation if this is plus minus. So what is the KVL equation for this particular circuit? What is the KVL equation?
10 into I.
Right, 10 into I of 0 plus, right? Agree? Okay. So what is this voltage plus minus? What is this voltage? Tell me.
So plus 12.
So plus, what is the voltage this one?
So
This
12.
is VC, right? This is VC. So VC of 0 plus, right? Agree? So what is the
Yes, sir.
voltage here? I'm unnecessarily confusing. I
VL,
see.
sir.
Okay.
Minus VL of 0 plus.
Okay. I think I'm confusing for some students. Okay. So this is the circuit, right? So this is the current. Okay. If this is the current, this is plus minus, right? So actually this will be plus minus, right? Okay. So that is what is the this is plus minus, right? This is the original one. If this is the current, but the given direction is plus minus. This is in the opposite direction, right? So that means this VL, what is the VL value? Plus VL into, sorry, minus VL of 0 plus, which is equal to 0. Agree? You agree for this?
Yes.
Okay, no confusion, right? Some may confuse that. So why we have written the minus sign? Because the assumed one is, so this is VL, so that's what we assumed. Okay, so that's why we have written so minus VL of 0. Minus VL of 0. So what is I of 0 plus? What is I of 0 plus? What
IL
is I
minus
of 0 plus? What is this
0
current?
So 20. So 10 into
2
2.
amperes. 2 into 10 into 2.
Exactly 2 amperes or minus 2 amperes. So
2
this is
amperes.
IL, right?
Yes,
So what is that
so
value?
minus 2. So minus 2.
Minus
So
2
this is
amperes.
minus 2, right? So 10 into minus 2 plus voltage across 0 plus. So what is voltage across 0 plus? So
So
VC of
12.
0 plus 12, right? Minus
Yes.
VL of 0 plus. This is we need to calculate. This is equal to 0. So from this, what is VL of 0 plus? What is VL of 0 plus?
minus 8 volts, sir.
Minus
So minus 8 volt.
minus 8 volts, right? So that means this is equal to minus 8 volts. So from this, what is di of 0 plus by dt?
minus 4.
Minus what is its value?
minus 4.
Minus 4
minus 4.
ampere per second. Understood, or I confused you? So just it's a matter of plus minus or the current direction, and everything we are solving at t equal to 0 plus. Okay. Right.
Sir,
If you are not understand
s-
100%, anyway we'll solve two or three more problems so that you can understand. So why exactly why we are using when to use KVL or when to use you might have confused, right? So here I used KVL. Again in the this one I used KCL here. Okay, so why I used KCL? Why I used KCL? So because I want to calculate the capacitor current, so that's why I used KCL here. And the next thing I want to calculate the inductor voltage, I used KVL here. Voltage KVL. So why I require voltage across the inductor? Because I know that D into this, I know this one. So L into di of 0 by dt equal to inductor voltage. So from that you can calculate the rate of change of inductor current. So that's why I used that expression, right? So what is it? What is left over? So I infinite and V infinite, right? So what is I infinite? What is I infinite? Inductor current infinite value. So for this circuit, what is I infinite? If there is no source, what is I infinite in this particular case? What is in I
0.
infinite here? In this circuit, what is I infinite if there is no source? Simple question.
0, sir.
0, right?
Infinite current, sir.
Why infinite? So what is the basic thing? Whatever the current is this, so that will be right. So that will be absorbed by the resistor. Whatever the voltage is there in the capacitor, that is absorbed by the resistor. So under that is the natural response, right? So that means that will tend to 0. Right. So that means this inductor current will tend to 0 here, and the capacitor will also tend to 0. So that means V at V infinite, so both will be 0. So basically that circuit will become something like this at I infinite and V infinite, right? So how the circuit will modify? So this will be the case, right? So this inductor is open circuited, right? So this inductor is open circuited. This is short circuited. So this inductor is open circuited means this current is 0. Okay, so this current is 0. So that means this is also short circuited. So whatever the voltage that is there in the resistors, so that is slowly absorbed, right? So therefore, so we can expect that I infinite, this is 0, and this is also 0. Understood? Infinite time, so whatever the energy stored in the inductor, so that is absorbed by the resistor. Similarly, whatever the energy stored in the capacitor, so that is also absorbed by the inductor, this one. Okay. So that is about so finding the initial conditions for one particular problem. So we'll try to solve some more problems. I have another one. This is slightly complex actually, right? So you never know. So what will actually give you a good result? Either KVL will gives you the good result, a quick values, or other things. So this 24 volts here, and this is the current I. So this 0.4 Henry on one side, this 0.4 actually. And this is 10 ohm, and there is a switch here. So this particular switch is closed at t equal to 0. So this is 2 ohm. This is 1 by 20 farad. That's all. So for this particular problem, so calculate I of 0 plus. So this is the voltage across inductor. Okay. So V of 0 plus. So di of 0 plus by dt. dV of 0 plus by dt. I at infinite and V at infinite. So what is I of 0 plus? What is I of 0 plus? The particular switch is closed at t equal to 0. What is I of plus?
12 ampere.
12 ampere.
12 ampere.
12 amperes, right? So why
Amperes.
12 amperes?
T is equal to 0. It's
So the
closed.
circuit is, so this is short. So this is short circuited, right? And this is open. So you have 12, this is open circuited under steady state. So you have 10 ohm here and you have 2 ohm here. So that means the circuit will be something like this. So this will be the circuit, right? Agree? So this is 2 ohm and this is 10 ohm. So what is the current I of 0? 24 by 12. So that is 2 amperes. Is this correct?
24 by 2, sir.
24 by 2. No, this switch is open, no? At t equal to 0.
Sir, but resistor is 2 ohms, no, sir.
This is 10 ohm, right? Understood?
Yes, sir. Yes, sir.
Yes, sir.
This is clear, right? So this switch is open at t equal, this switch is closed at t equal to 0. Okay, so that means for t less than 0, this 10 ohm is present. All right. No confusion, right? So what is the next step? So voltage across 0 plus. So what is V of 0 plus?
4 volt.
24 volt.
So this is open circuit, right? In the same circuit. So you have capacitor here. So what is the voltage? This is 10 ohm and this is 2 ohm. So this voltage, so that voltage across the 2 ohm, one side you have 24 volts. So that means 2 by 10 plus 2 into 24. Agree?
Sir.
Yes, sir.
Sir,
So this is 4
sir,
volts, right?
4 volts. 4 volts.
so that at t is equal to 0, sir, that switch is closed, sir. So then current will not pass through 10 ohm, right?
Mhm.
So 10 ohm resistor will be short circuited, no, after t is equal time t 0 second.
So this is all we are calculating for t is less than 0 only, right? This is the circuit.
Okay, sir.
Okay. This is the circuit for t less than 0 only. Okay. So here the thing is that we already just now we discussed it, right? So thing is that we obtain I of 0 minus. Okay. In true sense, we obtain I of 0 minus and V of 0 minus. Okay. So this is what we obtained. But the thing is that the inductor will not allow sudden change in current and the capacitor will not allow sudden change in current. So our conclusions are there. So whatever the value is there, so this is also same value will present. Okay. Right. So that is our observation. Understood. So originally you obtained these two.
Yes, sir.
From this you assume these two are same. Okay. That is the thing. Understood.
Yes, sir.
Right. So now we'll come to for t greater than 0. This circuit will be modified now, right? So how exactly the circuit is modified? So now this is short circuit, right? That means this is this no longer this 10 ohm resistor is there, right? Agree? The 10 ohm resistor is bypassed, right? Is this correct, my statement?
Yes, sir.
Yes,
This 10, this switch is closed, right? So that means this 10 ohm is bypassed, right? So there is no current flowing here. So this is 2 ohm and this is 20. Is this 20 or 1 by 20? I think 1 by 20 farad. I think 1 by 20 only, right? I had given right in.
yes, sir. 1 by 20.
1 by 20 farad. And this value is 24 volts. Okay. So what the initial conditions you got is I of 0 plus is 2 amperes and V of 0 plus is 4 volts. Right. So what is the first question? What is our first question is, for example, you want to calculate dV of 0 plus by dt. So this is the one you want to calculate, right? Okay. So here, how to do that? We already discussed that this is also equal to what is this exact value dV of 0 in terms of capacitor current? You have one capacitor here, right? So what is that exact thing?
Current
So
through
this is
capacitor by C, sir.
what is in terms of capacitor? What is this one? So will it
Sir,
be I capacitor of 0
I
plus
capacitor of 0 plus
by
by
C,
C.
right? Agree? So this is IC. So now tell me, so which is suitable? So how to calculate IC of at 0 plus? Which one is suitable? KVL, KCL, if it is KVL or KCL, so under which loop you need to apply, or at which node you need to apply KCL? So you want this current, right? So if you assume that this voltage is some Vx, this voltage is Vx, you can apply or no need to assume that voltage, right? You can simply apply KVL at this node, right? So what is KVL if you apply? Or if you assume this node is Vs, right? So what is you can what you can get?
IC
Vx
plus
minus 4.
Vx
Which one? No, tell me. So which is suitable thing?
Sir, loop loss.
Yes, sir.
What
Sir,
you say?
sir, loop method, sir.
Which loop method?
So means KVL, sir, we need to calculate, sir, because node voltage method we can't do, sir, because we'll have no relation for IC, sir.
Okay, yeah. What is the other method you can?
So loop current method, sir.
In which one you will apply loops?
Sir, in both, sir.
Right. So now tell me, right? If this is the ground point, right? So now, what is the voltage at 0 plus instant? Vx. So what is this Vx of 0 plus? Anyone tell me in this particular problem?
4 volt.
4, sir.
Why 4 volts? So you have only capacitor present, right? So this voltage is 4 volts, right? Agree?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So what is this voltage? This is 4 volts, right? Okay. Thing is that, so this is 4 volts. So now apply KCL. So this will, what is this value here? So this is Vx of 0 plus by 2 amperes. So that is the first one. So what is the second one? Second one is capacitor current IC of 0 plus. Agree? So what is the third one?
Yes, sir.
So inductor current IL of 0 plus. Right. So this is IL and this is IC and this is the resistor current IR, for example. So this is IR and this is IC and this is IL. Understood? So now tell me, so what is Vx of 0 by 2? What is its value? What is Vx
Sir,
of
2
0 by 2?
amperes.
2, sir.
It is
Two
2, right?
amperes.
It's true, right?
Plus what is IC? So this is the one we need to calculate, right? IC of 0 plus. So what is IL of 0 plus? So what is this current?
Sir,
Minus-
I0 minus,
Sir,
that
2
is 2
amperes, sir.
ampere.
Minus 2 amperes. No, sir.
Why minus 2
Minus
amperes? So this
minus
is
2
its
ampere.
original one, right?
Yes.
Okay. So but when you're modified that one, so that means it will be minus 2 amperes. So what is IC of 0 plus? So which is equal to 0 amperes. Understood? Or shall I repeat? Just simple things. Okay, it look like slightly complex or slightly confusing, but just simple things. Okay, this is the one I applied KCL. So here IR, IL plus IC. So the thing is that IR plus IL, IC plus IL, which is equal to 0. So this is what exactly this is. Okay, I applied KCL at t equal to 0 plus instant. Right. So this value I know. So this is the capacitor voltage. So that's why it is Vx of 0. If you assume that unknown node, so this value is equal to 4 volts. Why? Because so this is the one. Okay. So from this is IC of 0 plus. So this is equal to 0. So from this, you know this value. So now what is dVc of 0 plus by dt? which is equal to IC of 0 plus by C. So what is IC of 0 plus?
0, sir.
What is IC of 0 plus? So this is 0. So that means obviously this is 0 volts per second. 0 volts per second, right? Understood. So next thing is I of 0 plus by dt. Di of 0 plus by dt. So this is equal to L into d. So how to calculate this one? So this will be VL of 0 plus by L, right? Agree? VL of 0 plus by L. Understood? Agree?
Sir,
So
Vx
how to
of 0 plus
calculate inductor voltage, right?
Vx of 0 plus minus 24 by 0.4, sir.
Yeah. Wait. So this is the circuit, right? I will draw the circuit. It will be confusing otherwise. What is there here? Inductor is there, right?
Yes, sir.
This is 24 volts. So this is your current I, right? So this means this is your VL, right? Okay, in this particular case. So this is your VC. All right. So this is 2 ohm. So now tell me, so what is VL?
24 minus 4.
Yes, sir. 24 minus 4.
24. This voltage is 4 volts, right? That means this is at a particular, this is 4 volts. So that means 24 minus 4. So VL of 0 plus is 24 minus 4. So this is equal to 20 volts. So from this, right? So this will be 20 by, what is the L value? 0.4. So that means 50 ampere per second. So this is the one. Understood? Okay. Right. So here we have to use our simple techniques, either KVL, KCL, node voltage method, loop current method, or by observation. So we need to find out these values. Okay. Right. So there is no standard methods. So the method will vary from circuit to circuit. So most of the cases, either KCL or KVL, so will work out. Okay. So but you need to properly analyze the circuit and properly identify the current directions or voltage directions, right? Okay. Right. So I will give you one example. This inductor current IL is 0.6 Henry, and this is capacitor voltage VC. This is off farad. It's 20 volts. This is 4 ohm. All right. So this is voltage across resistor VR. Voltage across resistor VR. This is 2 ohm, and this is 3 U of t. 3 into U of t. So for this circuit, IL of 0 plus, DC of 0 plus, VR of 0 plus, VR of 0 plus. Similarly, DIL of 0 plus by dt, DVC of 0 plus by dt, DVR 0 plus by dt, right? Similarly, IL at infinite, VC at infinite, and VR at infinite. So all these three things, total 9 things you need to calculate. Right. So one thing you need to remember that, so VR of 0 minus, okay, so VR of 0 minus, for example, so which is not equal to VR of 0, right? Is this VR of 0? So this is wrong. All right. So why it is wrong? So this is only applicable for capacitor only. So
Yes.
resistor, right? So unlike capacitor, so it will allow sudden change in voltage, right? Sudden change in voltage. For example, it switches suddenly on, so 0 volt. So this is the voltage across resistor, right? It switches suddenly on, suddenly its voltage will become some finite value. So this is wrong. Similarly, this is not equal to VR of 0 plus. So this entire thing is wrong. Okay. So this is only this relation only is applicable for capacitor voltage and the capacitor inductor currents. Okay. So this is also not applicable for capacitor currents and inductor voltages, right? So that keep that in mind. Okay. Similarly, if you know the DRI GT, you cannot directly differentiate. For example, if you got this is 3, right? If you differentiate this one, obviously you will get 0 only. For everything, you will get 0 only, right? So that is also not correct, right? So try to solve this one. I have some answers. Let me see. Here I will write one by one. So this is in order. So 0 volts, minus 20 volts, and also this is 4 volts. Okay.
Sir,
Yes.
sir, that 0, minus 20, and 4 are the answers of IL, VC, and VR.
This. Okay. So this first one, this is an order, right? I told you. This is the one. This is the one. This is the one. No confusion, right? And these answers
Yes.
I will provide. Just a second. This is 1 ampere. This is 4 volts. This is minus 20 volts. All right. This is 2 by 3 volts per second. Volts per second. And this dVc of 0 by DIL of 0. So this is 0 ampere per second. And dVc of 0. dVc of 0, I think. Okay, I have no answer for this one. Actually, I could not find. Okay. Okay, I could not find. So anyway, we'll solve these things in next class. Okay. Right. We'll solve this one in next class. we'll stop here.